Hi everybody, it's Mr. Defy. This video is about trigonometric ratios, specifically about the law of sines. In this diagram here, you can see that I have color-coded certain things according to their type. Now, just to be very clear about this, if you look at the coloring of it, I have angles and sides marked in the same color. So here I have angle B, here I have side B, here I have angle A and side A, and we have angle C and side C. And what you should note from that is that the angles and their corresponding sides are opposite from each other. And this creates the relationship known as the law of sines, which says that any side over the sine of the angle belonging to that side is equal to any other side over the sine of its own angle. Okay, and I can do that a total of 3 times because a triangle has 3 sides and also 3 angles. So what we get over here is this connection between these ratios, A over sine A equals B over sine B equals C over sine C. And normally when we do calculations involving the law of sines, we will only really use 2 ratios at a time. And they are interchangeable with each other because all 3 are equivalent to each other. And so I could, for example, pair up 1 and 2 with each other. And so these first 2 that you see over here, or if I didn't want to do that, I could pair up B and C with each other. Okay, those 2 over there. It really depends on what it is you're trying to figure out. And so by that, you would know what you need to pair with what. Okay, let's go ahead and look at our first example. In the first one, I already have that degrees circled there. But in the first one, we have 99 degrees. And to the right and left of that, we have 11 centimeters. Now, I want to note that this is not a right triangle. And you should know that right away by looking at the degree measurement in there. The nice thing about the law of sines is that it applies to any type of triangle. So no matter if it's scaling, obtuse, acute, whatever it is, it doesn't depend on the triangle being a right triangle. And so from that, we are freed from the limitations of regular trig ratios, which we looked at earlier. And so if I look carefully here, I see that there's some information that's missing. Angle F, I don't have. Angle E, I don't have. And I also don't know the side of the length of EF. Now, it's important to note also, when you're doing the law of sines, because you will be using 2 ratios at a time, for example, these 2, as an example, okay? It's important to note that in any proportion, you always need to know 3 out of 4 pieces of information. Because if you look carefully, there are always 4 things given to you. So you have 1 thing there, you have 1 thing there, 1 thing there, and 1 thing there, right? So if you have an unknown, that unknown must be the only unknown out of the 4, which means that 3 of those 4 things you see with the black dots next to them, 3 of those need to be things that you do know. A number, a measurement of an angle, the value of sine of something. You need to know something, and that will leave you the freedom to discover, by calculation, the value of the unknown, okay? It'll become more clear as we get through this example here. Now, when I look at this example, I see that because I only have 1 angle inside, it's not enough. It's not enough. And the reason is because when you apply the law of sines, you need to have 2 angles. See, as in the case over here. You look there, I need an angle here, and I need an angle there. Well, if you look at my example down here, I only have 1 angle measurement to work with. That will not be enough. Fortunately, though, I'm given enough information to figure out the value of those 2 other angles. And I know that this and this are equivalent, which means that this side is congruent to this side, which also means that this angle is congruent to that angle, making this triangle an isosceles triangle. Okay, and so I'm going to figure out the value of this by assigning a variable to it. We'll call it x, or you can call it, we'll give it a more sophisticated name, like theta, okay? Theta. And so if I want to figure out the value of theta, the measurement of that angle, what I have to do is set up an equation, and it would be this. It would be 2 theta, since I have both of them, plus 99 is equal to 180. Okay, and then I just do some simple math, and 180 minus 99 would be 81. So it's 2 theta is equal to 81, which means that theta is 40.5 degrees. Okay? So the value of each of these angles is 40.5 degrees. So 40.5 and 40.5 degrees. So this is very helpful for me because now I have all the angles inside the triangle, and that leaves me with just one thing to figure out, which is what is the length of EF? And so now I have freedom to use the law of sines to do this. Okay, so I'm going to incorporate some of these relationships that you see over here. So going back over here, I'm going to pair up my angle, which is right here, with its opposite side, which is right over here. Okay, and instead of a question mark, let's give it a more professional looking name. Like, for example, we'll call it little d. Okay, so big D, little d. All right, so here I go. I'm going to say little d over the sine of big D is equal to, and now I can choose whichever other angle, and whichever other side that I want. Okay, keep in mind that this is big F, therefore this is little f, and this is big E, so therefore this is little e. Okay, little e. So plugging this in, what I get is, or finishing this relationship, what I get is little d over sine of d is equal to, I'll go with e, so is equal to little e over the sine of angle e. And that means that I really don't need to use angle f at all, or the side opposite of that. I don't need those things. I have everything I need. So instead of sine of d, what I will have is the sine of 99 degrees. So this is now d, little d, over the sine of 99. Instead of little e, what I have, as you can see over here, the value of that side is 11 centimeters. So this becomes 11. And the angle opposite of that is 40.5 degrees, as we figured out earlier. So the sine of 40.5 degrees. Now I need to do a little calculation here. So the sine of 99 is 0.987. So I have d over 0.987. This is still 11. The sine of 40.5 is 0.649. In order to solve this, I have to cross multiply. So this multiplies here, this multiplies there, and what I get as a result of that, just bringing the work over here, what I get is the following. I get 0.649 d is equal to 11, actually, yeah, I'll set it up. So 11 times 0.987, okay? And so the value of d will be whatever my outcome is from here divided by 0.649. So let's see, 11 times 0.987, 11 times 0.987 is 10.857. So 10.857 will be divided by 0.649, just using my algebra skills here, okay? So dividing that by 0.649, what I get is 16.7, and that is the length of my longest side, okay, which is side D, and that's my answer. So 16.7, and we have to apply the units since they're given for the other one, so centimeters. And that's how we use the law of sines. Now, this could be used to figure out the value of an angle as well, if it's necessary, but really most of the time what we're going to use it for is figuring out the lengths of sides. It's very versatile, very flexible, because again, it doesn't depend on just having a right triangle. So I hope this example helped. Um, Please stop by, leave me a comment, and as always, thanks for watching. Bye-bye.